The main motivation for Numgeese becoming involved in aquaculture really just relates to our dependence on salmon for our survival. Salmon has sustained our people for thousands of years, and it's integrally woven into all aspects of our cultural life. And so for us, salmon, wild salmon, is not just a source of food, it's our survival. There's been a proliferation of aquaculture fish farms within our territory, and that was a concern that motivated us to explore the feasibility of establishing a land-based aquaculture facility on our traditional lands.
In terms of what Kuterra is trying to achieve, they saw that retail stores were making sustainable seafood purchase commitments, and that there was no one out there producing Atlantic salmon in a sustainable fashion. They also knew that fish produced in a recirculating facility do not use pesticides or antibiotics, and so there's a whole group of consumers out there for whom a healthy product and a sustainably produced product is paramount in terms of their purchasing decisions.
Kuterra represents the future of modern salmon farming. It's at the forefront of aquaculture technology, and it pushes the boundaries because we use state-of-the-art technology to recycle and to reuse the vast majority of water in the system. That allows us to have much greater control over all the things that are important to the fish, and so create optimal conditions for them to grow in 24/7, so that the fish are happy and content, and as a result they perform very well. I think the main feature of this kind of technology is that it separates the farmed environment from the wild environment. By doing so, we don't negatively impact on local ecosystems. It's impossible for fish to escape, and really there's no risk of disease transfer between wild and farmed fish. This is the first module of the Kuterra operation. It's a 470-ton pilot-scale facility designed to test the technical and the economic feasibility of growing Atlantic salmon on land in tanks all the way up to market size. And it's a perfect location because we're close to the road, we're close to three-phase power supply. We have great quality groundwater here and lots of volume.
So this is our quarantine facility. And when we get fish here at Kuterra, they come in at about 100 grams in size, and they're vaccinated already when we get them, but we keep them in here for 3 months just to make sure that they're absolutely clean before we take them into the rest of our facility. So after 3 months, they're about 600 grams in size, and at that point we would then use a fish pump and grader, and we would grade them into the rest of the building. So this is the main grow-out area of our farm. After the fish have left the quarantine unit, these are the tanks that they come out to. These tanks are twice the size of our quarantine tank, and this is where the fish are going to stay until they reach their harvest size. So other than getting graded once, there's no more handling for the fish, and this is where they spend the remainder of their time here at Kuterra.
So in these kinds of facilities, we have the ability to feed the fish 24/7. So by using continuous light, we can feed for 24 hours. The feed we give the fish is it's a fairly standard diet. But that said, because we create optimal conditions for the fish to grow in, all the things that are important to the fish, the oxygen, the pH, temperature, we maintain them at the perfect conditions for the fish, so that they make much better use of the feed they're given, and as a result their food conversion rates are much better. So not only in these kinds of systems can we grow the fish in half the time by creating optimal conditions, we can do so using up to 30% less feed, because the feed they use is converted much more efficiently.
So all of our main systems here at Kuterra are monitored through a central computer system, and it allows us to very quickly and easily check temperatures, oxygen levels, and it also automatically lets us know if there's any alarm conditions. So for example, at night, if there's an alarm, this computer will call you at home and let you know. And at home, you can go onto the internet and look at these exact same screens and see what the problem is. So, you don't necessarily even have to come out to the site to answer an alarm, depending what it happens to be.
You can imagine these large tanks full with fish. The fish feed, they get bigger, they grow, and of course they produce waste. These tanks are designed to be self-cleaning, which means that the waste leaves with the effluent. The first thing that the effluent encounters is these mechanical filters, and these filters remove the suspended solids. That water then flows onto what's called a CO2 stripper, and what happens there is the water molecules come into contact with large volumes of air. That removes the carbon dioxide and adds oxygen. That water then, having had its suspended solids removed, the CO2 removed and oxygen added, is ready to be distributed to the biological filters. Those filters contain different species of bacteria that consume and remove the metabolites that the fish generate. So that water then is essentially clean and is ready to be distributed by the pumps to the tanks.
In my capacity as the independent environmental monitor working for the Pacific Salmon Foundation, I'm basically interested in looking at the water quality of the effluent products from this facility, which basically means looking at the water quality of all steps of the operation, from the well water coming in to the production water that the fish are growing in, to the effluent water out that is discharged from the facility. So the way the flow works is the supply for the facility comes out of 3 wells that are located about 300 meters from the Nimkish River. From there, the water is pumped into the facility, and 98% of the water used is recirculated. So less than 2% is overflow water, if you will, or makeup water. All effluent is discharged into the chlorination tank. It then goes into a dechlorination tank, and then the resulting clear effluent is discharged to ground in these open infiltration basins.
So when we're harvesting the fish out of the purge tank, we crowd them up and we use our fish pump to pump them out of the purge tank. They go up onto the tower where they get dewatered. They go through a digital counter and they come out onto our harvest area where they get stunned and bled. It's about 30 seconds from the time the pump takes them up to when they come out.
Well, we formalized our relationship with Kuterra because we wanted to really be involved in this new part of the industry. We really believe that Kuterra has the opportunity to be a game changer and answer some concerns that individuals have about conventional aquaculture. So demand has really exceeded supply. We've got strong interest from all over North America, great customers in Toronto that continue to ask for this product. Customers in Washington, D.C., in California, in Boston that are asking when they can get this product. So we're really looking forward to the day Kuterra has more product available. The response from the chef community has also been really overwhelming.
Well, first of all, the quality of the fish is extraordinary. The taste is great. The look of the fish is fantastic. And hopefully we can just get more of it and continue to replace some of the open ocean farm salmon with this closed containment, land-based Kuterra product. And I know that I'll be a happy chef and I'll be able to make more happy customers.
Well, the more fish we grow, the more we learn, that's for sure. Even though we're still ramping up production, we've had a lot of successes. Just to give you an example, we certainly learned the importance of having a reliable supply of smolts, both in terms of timing and quality. Another outstanding technical issue is our oxygenation system, which is on a scale never attempted before, and it's not quite as efficient as we would like it to be. But we have investigated, we know where the problems lie, and we know how to fix them. And the last of our outstanding technological issues will be resolved by the end of this year. And now that we are consistently harvesting sustainable product, the next phase is all about maximizing the biological, the engineering, and the operational efficiencies, and producing a superior product that is consistent both in terms of timing and quality.
In this process, we've been able to debunk a lot of myths that have been out there. Many people said this couldn't be done. One of the myths is that it would take too much energy in terms of pumping the water through the facility. Energy costs for us aren't even in the top 3. We've been able to show that with many energy efficient design features, energy costs are very reasonable. Also, we're looking at developing ancillary or additional revenue streams by utilizing the waste that the facility produces. We want to turn that into a soil amendment, for example, that we could sell in stores. It's very rich in nutrients for plants. This is just, after all, a very small pilot facility. We want to be able to extrapolate those results and show what the economics would be for building a full-sized commercial facility that, instead of growing 500 metric tons a year, perhaps grows 2,000 or 5,000 metric tons a year, and thus obtains the economies of scale that come with building at that size and scope.